You came on my radar when you were discussing Oumuamua. Is that how I
Yes,
say it?
that's the right.
Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial in origin, meaning from some sort of a civilization.
Right.
Yeah. Why did you? Please explain to people what Oumuamua is, why it's so extraordinary, and why you think it's possible that it came from some other intelligent civilization.
Right. So I'm a scientist, and I basically follow the evidence, just like Sherlock Holmes, trying to find solutions. It's a detective story. You have some anomalies, some things that don't quite match what you expected, and you're trying to find an explanation. And the thing about Oumuamua is that it was discovered on October 19th, 2017, a little more than 3 years ago. And it was the very first object that visited our vicinity in the solar system from outside the solar system. It moved too fast to be bound to the sun. Very first object that we have found coming to us from interstellar space, from other places. And at first, astronomers said, oh yeah, it's probably just like the objects we had in our solar system, all the rocks that we have seen before. We've seen comets and asteroids. So a comet is a rock that is covered with ice, water ice. So when it gets close to the sun, the surface gets warmed up and the ice turns into vapor, gas. And you see this beautiful cometary tail behind it. That's what a comet is. An asteroid is just rock without much ice on it. Actually, the first person to explain what comets are was at Harvard, the university that I am affiliated with. And the story goes that, I mean, it was Fred Whipple, that he went to Harvard Square and saw all the slush during a winter day, and came up with the idea that it's just icy rock or icy rocks or, rocky ice. And that's what a comet is. And the comets come to us from the periphery of the solar system. And, astronomers said, okay, other stars may have them as well. And, since they are loosely bound, if they are in the periphery, they can be easily ripped apart from their host star. And some of them will fly in our direction. We will see them. So they said, Oumuamua is probably a comet. The only problem is there wasn't any cometary tail. So you look for a duck, but it doesn't look like a duck, So then the question is, what is it? And so people said, okay, it's just a rock without any ice on it. Then the problem was that it exhibited an extra push away from the sun. And usually you get it from the rocket effect. That when you make the cometary tail, it pushes the object in the opposite direction, just like a jet plane. A jet plane works by throwing gas out, and that's pushing you forward. So a comet has an extra push when it evaporates. But there was no cometary tail, so why did it show an extra push? That was the key question in my mind, at which point I started thinking, maybe it's not a comet and not an asteroid, something else, And the other strange thing about it, it changes its brightness by a factor of 10 or more. And the brightness of the object, the light that we see, is simply reflected sunlight. So just think about it. Think about a piece of paper, razor-thin piece of paper, tumbling in the wind, and changing the area that we can see, the projected area of that piece of paper, by a factor of 10 as we look at it. That's exactly what we inferred from this object spinning around every 8 hours, but changing its brightness by a factor of 10, meaning that the area projected on the sky that we see, that reflects sunlight, changed by a factor of 10. So that means it has an extreme geometry. Most likely flat, if you try to interpret the light that it reflected over as it was tumbling around. And so a flat object, about the size of a football field, that has an extra push. If it were a comet, it needed to lose about 1/10 of its weight. So a lot of evaporation. You can't just say, oh, it's a little bit of evaporation, and therefore that's why we don't see it. it should have lost a tenth of its weight. If we go on a diet and lose a tenth of our weight, that's a big chunk of mass, right? So this object didn't lose that because we didn't see it. And the Spitzer Space Telescope looked very deeply behind it to see if there are any traces of dust or gas. Didn't see anything. So then, just like Sherlock Holmes, I was trying to think together with a postdoc of mine, Shmuel Bialy, what could explain it? And the only thing that came to mind is reflecting sunlight. So the object itself is being pushed by the sunlight reflecting off its surface. And, that would agree with everything we know about the object. But in order for it to work, the object needs to be very thin, like a sail, the sail on a boat. So a sail is pushed by a wind. But you can also push an object, a thin object, by light. And that is called the light sail. And we're actually using this technology now, developing it for space exploration. The big advantage is you don't need to carry the fuel with the spacecraft. You just reflect light off it and it's being pushed.
There's a science fiction movie that did something like that. I think it was called Sunlight.
Quite possibly. I should mention an anecdote. In September, just a few months ago, in September 2020, there was another object that showed an extra push, no cometary tail. And then astronomers gave it a name 2020 SO, okay, September 2020. And then they extrapolated back in time and found that it came from Earth, actually. And then they looked at the history books and saw that indeed there was a rocket booster from a lunar lander that was kicked into space, and this is the object. Now, why did it show this push? Because it's a very thin structure. So here is an example where we can tell it's artificial, and we know that we made it. But Oumuamua could not have been made by us because it was passing near us just for a few months, very quickly, faster than any rocket that we can launch. That's why we couldn't really chase it when it was receding away from us. And it came from outside the solar system. So, I just do 1 + 1 = 2. I say, okay, it looks very peculiar. Maybe it belongs to another civilization. I just put it in a scientific paper. I didn't think, we didn't have any press release. Then it went viral. The public got extremely interested. And the thing that really surprised me is that my colleagues were pushing back. They were very upset that this possibility was even mentioned. We had a seminar, a lecture about this object at Harvard. And a colleague of mine, after the lecture, said, "This object is really weird. I wish it never existed." Now, to me, that I was really appalled by this. How can you say something like that? You should be happy about whatever nature gives you. You learn something new. If something doesn't look right, it actually teaches us, it's a learning experience. We learn that we have to revise the way we think about reality. That's a good thing. That's not a bad. You shouldn't always be in your comfort zone and think that the future will be the same as the past. So I actually see it as a blessing.